Hello everyone. Today, I will discuss how to set up machine learning or ML payload processing configurations using direct measurement processing or DMP. Today's agenda includes the benefits and features of machine learning or ML payload processing using DMP and how to set it up. Before moving forward, it's important to keep in mind that this functionality is available in version 26.4 onwards. ML is currently only available in SaaS with SGG native adapters. Refer to the Administrative User Guide for more details about configurations, scenarios, and performance-related configurations. Let's start with the benefits and features of machine learning payload processing using DMP. Machine learning-based payload processing uses IMD staging or in-mem tables, which enables batches to upload payload files from Oracle Object Storage into IMD control staging tables on a temporary basis for processing. This functionality only creates IMD records, if there is an exception. This also enhances functionality to better support frequent read acquisitions and event-based processing. This feature further strengthens business and operational benefits such as quicker processing and faster access to data and significant reduction in storage costs, which further minimizes the need for additional storage capacity. Please make a note that currently this feature is only available in SaaS with SGG native adapters. ML processing functionally does the same thing as the D1IMD batch control, but it is much faster. This is because there are fewer database inserts and updates, meaning less database commits, resulting in higher throughput. And since we are not creating IMDs for good measurements, the overall database is reduced. ML is only used for measurements coming from an SGG native adapters system. It is not used for manual reads or system-generated measurements. This represents the functional architecture of ML-based payload processing. Let's go over the flowchart. Here, the SGG native adapters store payloads in Oracle Object Storage in file format. These payload files are processed by executing the D1PLPSO batch. Next, the batch loads the records into the IMD control staging table, setting the status to waiting for ML. Additionally, this batch routes the records to Oracle Object Storage in a separate folder for data science. Then once ML is executed using simulation, the reads are scored and updated, after which data science publishes the results to Oracle Object Storage. Next, we run the D1PL-MLP batch to import the scored and updated reads from Oracle Object Storage. The system validates read tolerances, and if they meet the threshold criteria, it updates the status of the reads to ready to process in the IMD control staging table. If the results do not meet the threshold, the reads are processed through standard MDM validations, or the VEE procedure. For example, the initial load VEE process. Finally, we execute the D1IMDCS batch to move IMDs from the staging table to the final measurement table. Now, let's talk about how to configure or set up ML processing. The following presentation includes screenshots from the C2M demo database. Projects should have a copy of this demo database to refer to for configuration examples. Please refer to the C2M demo scenarios catalog under Extendable Lookup for more information on the specific ML scenario provided. You will notice we include details on the demo scenarios such as scenario description and related object details. This highlights the scalar and interval channels for Muid or Larry as part of the demo data. please review the head-end IMD types provided. IMD types are configuration records used to define how initial measurements are processed using direct measurement processing. IMD types contain the logic for validating and processing reads. The types include the algorithms required to process reads, like pre- and post-VEE. Set up the head-end system in processing methods. Please note, IMD types are required for ML processing using direct measurement processing. Make sure you use the head-end IMD types provided for each native adapter. For MC type, ensure that in your MC type portal, both options enable ML-based validation and initial load IMD ordering are enabled or set to yes. Otherwise, the system will fall back. In the measuring component, make sure that the enable ML-based validation and initial load IMD ordering features are enabled or set to yes. Make sure your devices have the correct head-end system. The next step is to add SGG payload processing configuration. Go to Extendable Lookups and add or edit an SGG payload processing configuration. Make sure you have a configuration value, and make sure you are using the proper SGG payload handler class name, as shown here. You also must select Use IMD type to use ML with direct measurement processing. Now add the SGG ML payload processing configuration. Go to Extendable Lookups and add or edit an SGG ML payload processing configuration. Make sure you have a configuration value, and make sure you are using the SGG ML payload handler class name, as shown here. You also must select Use IMD type to use ML with DMP. Next, you will need to set up object storage or file system locations. Note that this demo uses native or local file servers for readings and ML results. However, SAS requires Oracle object storage. Here, you can see examples of both. To configure this, go to Extendable Lookups and search for F1 file storage. Then, create a file location shortcut based on where your data will be retrieved and stored. Remember the shortcut value you specify. You will need this later on. Finally, specify a server directory or object storage path. Now, run the batch job D1PLPSO for SGG payload processing with DMP. Here, you can see that the file locations use the file location shortcut created on the previous slide. Next, find the SGG processing configuration value that is Extendable Lookup value name. Please note the export file location so the ML simulator tool can pick up the file. After the successful run of this batch, the records are uploaded into the IMD control staging table within the MDM staging table with read status waiting for ML. In the MDM staging table, you can see the payloads in standard XML format. Please note, these records are not stored in the actual MDM tables. Next, we run the batch job D1PLMLP for SGGML payload processing. Here, the XML files need to be imported after the ML simulation tool calculates the score, along with the updated data reads. Notice that the file locations use the file location shortcut created on the previous slide. Also, please note that the SGG processing configuration value is Extendable Lookup value name. After the successful run of this batch, the ML data is uploaded into the IMD control staging table within the MDM staging table with read status ready for process. In the MDM staging table, you can see the ML score value with updated data in standard XML format. Please note, these records are still not stored in the actual MDM tables. Finally, we run the batch job D1IMDCS to process IMD control staging data. Here, the batch picks all the payload records or rows that are in ready for process status within the IMD control staging table, processes them, and stores them directly in the final measurement table within MDM, without any corresponding records in the IMD tables. Please note, with ML using DMP, IMD records are only created when there is an exception. If there is no exception, we show the final measurement values on the interval zone within the 360-degree view portal. For more information about this feature, see the user guide or 26.4 release readiness on Oracle Help Center, which is available at docs.oracle.com. This concludes this presentation. Thank you for watching.